Hello. Today we're looking at energy equations and when to use them. During the course of the film, there are questions, and when you get to those, just pause the film, see if you can answer them, restart the film, and see if you've got them right. At the end, when you've done all of that, if you can, complete the quiz. To start with, though, you need to make sure that you've got a pen, pencil, and a calculator. So if you can go and get those, and then we can continue when you're ready. Last lesson we were learning about elastic energy. So here's a few questions for you to see if you remember anything. So what is elastic energy? What is elastic energy measured in? What is the equation for elastic energy? And question number 4. If a spring is stretched a distance of 0.25 meters, how much energy is stored in it if the spring constant is 80 newtons per meter? Pause the video, give those ones a go. How well did you do? Elastic energy is energy which is stored in an object which is compressed or stretched, such as a coiled spring or an archer's bow. Elastic energy is measured in joules, after him, and the equation for elastic energy is E equals half ke squared. If a spring is stretched a distance of 0.25 meters, how much energy is stored in it if the spring constant is 80 newtons per meter? Start off by writing out your equation. Fill in the numbers. Remember bid mass, so do your indices first. Don't forget your units, 2.5 joules. A couple of things about energy, which you should also remember. Energy is what you need to make things happen. So nothing happens without energy. It's actually forces that make things happen, but without energy, nothing can happen. We can think of energy as existing in different energy stores. Energy cannot be created or destroyed. It is just moved from one energy store to another. When this happens, work is done. Work, like energy, is measured in joules. And here are our 8 energy stores. The electrostatic store, kinetic store, magnetic store, elastic, gravitational, thermal, chemical, and nuclear. Now what we're looking at today is how do you identify and apply the correct energy equation to different situations. Now you don't need to worry too much about this. We're going to be talking about the three equations that we've come across already. So you've got equations for kinetic energy, for elastic energy, and for gravitational potential energy. So let's have a look at each of these in turn, just to remind you about them. First of all, elastic potential energy. This is when objects are stretched or compressed. The equation is E equals half ke squared. E is the elastic potential energy measured in joules. K is the spring constant measured in newtons per meter. And E is the extension measured in meters. So that's elastic potential energy. Kinetic energy is when something is moving and the energy it has because of its speed. E equals half mv squared. E is the kinetic energy, m is the mass measured in kilograms, and v is the velocity measured in meters per second. And finally, gravitational potential energy. This is the energy that objects have because of their position as they're raised up against the force of gravity. So E is the gravitational potential energy, m is the mass measured in kilograms, G is the gravitational field strength measured in newtons per kilogram. On Earth, G is about 10 newtons per kilogram, but if you went to the moon, it would be much less. If you went to a planet like Jupiter, it would be much greater. And h is the height. Well, let's consider a catapult. There we are. There's a catapult done for you. Now, I've put a little spring on it. This is based on a Roman catapult. But there they had a thing like a bow that actually pulled the catapult upwards. Here I put a little spring. Now, when the catapult goes down, the spring is compressed and it stores elastic energy, E equals half ke squared. But as soon as you fire it, then that energy gets transferred into gravitational potential energy as it moves upwards, and also into kinetic energy as it's moving forwards. So all of these three energy equations are involved in the process of a catapult. You've just got to consider where in the process you are.
Birmingham. Chip line out to here and then we'll turn around. Oh no, waiting for video. Am I attached? Oh, I certainly hope so. Wouldn't look good on my resume if you went. No, it wouldn't.
Alright, this is Simon from UK. Okay, stop there. Stop.
Okay, come forward.
Come step back.
30 seconds, back dive.
Okay, shuffle back. I got you. Heels on each. Right over.
Okay, stop.
Over there, Danny. Okay, now. Look over your right shoulder down to the camera, to the way. And back over this way. Okay, now, I want you to lean back. Lean back. Don't you grab me.
Ready?
Yeah. Yeah.
5, 4, 3, 2, 1.
It's the third clip down that we watched, the world's highest bungee jump. The others are good as well, so you can always have a look at those if you fancy it. Also, while we're on the subject of things on YouTube, there's this one, how to make a catapult. I was tempted to do this myself, but I didn't really have time. But it's something you could have a go at. So, if you've got a moment or two, why not go and make a catapult out of some bits and pieces you've got lying around the house? I'd love to see pictures of those if you managed it. But back to our bungee jumper. When he's resting, when he's standing there, he's got gravitational potential energy. And if someone applies a little force, off he goes. Now that gravitational potential energy turns into kinetic energy. Right, as he goes down, and then that stretches, it stretches the bungee cord, and it turns into elastic potential energy. So for the bungee jumper, he has gravitational energy, he has kinetic energy, and he has elastic potential energy. Got me thinking about roller coasters. Now, roller coasters are good examples about how you get different energy transfers, kinetic energy and gravitational energy. Got me thinking about Thorpe Park. This is I took this off their website. Okay, so it's opening times today. It's closed. No surprises there. Made me think about the time I went to Thorpe Park, the detonator, and the vampire. Wow. Okay, well, let's look at some questions. And it's literally, what equation would you use in each of them? So, 3 questions here. We're going to take G to be 10 newtons per kilogram. Okay, a 5 kilogram bag of rice sits precariously on the shelf of a store cupboard 2 meters above the floor. How much gravitational potential energy does it have? A mouse with a mass of 5 grams falls off the bag of rice having chewed a hole in it. The mouse hits the floor at 4 meters per second. How much energy does it have? Finally, Aaron is bored. He spends 3 hours catching the mouse, then loads it into his homemade catapult. If the elastic is stretched 10 centimeters and the spring constant is 3 newtons per meter, how much energy is stored? So have a think about that. It's just, what equation would you use? Can you remember your equations? Have a think about that. Okay, what equation would you use? Okay, the first tip is to have a look through the variables. So here we're told the mass is 5 kilograms. We're told a height of 2 meters. And we're told that it's gravitational potential energy. So this one's nice and easy. Just need to remember the equation for gravitational potential energy. It's this one here, mass, height, and G. G is 10 newtons per kilogram on Earth. Second one. A mouse with a mass of 5 grams. So we're told a mass, we're told a velocity, and we're told that it's kinetic energy. So it's the equation for kinetic energy, E equals half mv squared. So there's looking at the variables, the information that you're given, and also a bit of common sense really, looking at the question. So the next one, it's a catapult. So if it's catapult, it's talking about elastic energy. You've got an extension of 10 centimeters and you've got a spring constant of 3 newtons per meters. So that's going to be our equation for elastic potential energy. Okay, so let's have a go at some real questions now to finish off. Now try these. Again, take G to be 10 newtons per kilograms. Get out your calculator. Give these ones a go. Check your answers once you've started the video. How well did you do? Remember, as before, Start off by writing out your equation. Remember bid mass, brackets, indices, divide, multiply, add and subtract. So we will need to work out the 15 squared to start off. You should have an answer of 84,375 joules. Next one, equation. That's the equation for gravitational potential energy. And the third one, a catapult. Extension is 0.1 meters. You need to be careful with some of these questions. If they give you something in centimeters, you need to convert it into meters. Again, write down the equation. Remember to work out your indices first. Come up with an answer of 0.1 joules. Okay, thanks for watching. Now go and have a go at the quiz, see if you can answer the questions. And I'll see you next time. Okay, bye.